Thank you, everyone. My name is Mario, and I'm a software engineer for Red Hat, and I work on the Podman team. And I'm excited today to talk about volumes of type image, so new type of volumes that is coming in Kubernetes. So first of all, this is about a new feature in Kubernetes that has been proposed less than 1 year ago with this request for enhancement. And it's about adding another type. So you can specify, you should be able to specify images as volumes that you will mount in containers, in pods in your Kubernetes cluster. So that's basically, this is the specification. So you have a regular pod here with a volume, and if you look at the volume definition, there is an image, so there is a reference, and the reference is actually the reference to an image. And so what you get is kind of a volume that is mounted inside a container that is based on another volume, so you have one volume inside another volume. And that opens to a lot of use cases, so a lot of new use cases that you will be able to do with Kubernetes. So there is a blog post that Sasha has written, that talked about Rust before. And because in version 131 of Kubernetes, we introduced that as an alpha feature, and it will become a beta feature in the next release of Kubernetes 1.33. Now, I would like to talk about the use cases, why this is interesting, and what has driven that. So the reason that has been implemented so rapidly, and the main interest today is for AI use cases. And basically, what I'm showing here is you should able to distribute, you are able with volumes of type image to distribute your models as OCI images that will be mounted in the pod where actually the inference runtime is running. So, and I will show rapidly. So what is that? So it's something I've written some script to actually do that. And this is the deployment for an example of a pod that is doing that, so that it's serving a model. So the model is here in the image that is below. That is the small LM model, and it's mounted inside a Ramalama pod. That is actually, Ramalama is a cool tool that we have been developing for easily run LLM models in containers. It's basically, Ramalama is for running containers and running models locally, so on your laptop, but it can produce also the YAML to deploy that on Kubernetes as well. So this is the result. And yeah, I've put the link to the source code in this slide. And this is the first case. So this is about mounting data, and in this case, a LLM model inside a container. Another use case is adding tools. Maybe you may want to have some debugging tools. You want to add tools that will help you for observe or do some debugging inside your container. And in this case, you can have an image. For example, here, the example that I've provided here is you could have an image where you have the executable for the Open VS Code server. And if you mount that in the container, you will be able then to start VS Code inside the container and to actually open, so connect to it via the browser and modify or debug things that are happening inside the container. So, and that's, this is the example code for actually running it. And here I'm using Podman to run it. I wanted to have this second example with Podman because Podman and Docker are starting to support volumes of type image as well. So you can run and test those kind of volumes locally as well. Yeah, so it's, in this case, the line that mount the image is this one. All right, so this is the two use cases, and that here is the current status. So it has been introduced as an alpha. In Kubernetes 1.31, it will graduate beta in 1.33. Cryo and Containerd support that, as well as Podman and Docker. And Cryo and Podman also are starting to support generic OCI artifacts. So you don't need to, it doesn't need to be a container image. It can be a generic OCI artifact. And that's all I have. These are links to the presentation with the slides and other information if you want to get more details about that. Thanks, everyone.